Okay, so here is the formula. I know that I want it to go back from the back legs 2 inches. I know that the distance is between the two legs is 21.938 inches. So that's equal to the 20 and 7/16 plus 3/4 for each dovetail height. It gives me 21.938, and I'm rounding to the third place because that's what my micrometer measures in, 0.001 or thousandths. So then if one applies the Pythagorean theorem, you get a squared plus b squared is equal to the circumference is equal to the hypotenuse, c squared. So the hypotenuse is going to be the radius of this circle. So I've got a circle, I've got a line bisecting the circle. That's the line between my two back legs. I know I want it to sag back 2 inches. So the two things that I know is I've got 2 inches and then the distance between the two legs divided by 2 because this line bisects in half. So that comes out to 10.969 of this number here. So I know that the radius of the circle is equal to r, and this part of the right triangle that I'm making is r minus 2. This is r. So we have one variable, r. So we should be able to solve for it. So using the Pythagorean theorem, AD, the length of this leg is 10.969, square it, r minus 2 and r, square r minus 2, square r, solve for r. So the thing I had to figure out, r minus 2, I used to have all this memorized. That's equal to r squared minus 2 times the product of these two numbers plus this number squared. So r squared minus 2 times 2r minus 4. I'm sorry, plus 4 is equal to r squared. So the r squareds drop out and you come up with r is equal to AD squared plus 4 divided by 4. So r is equal to this squared plus 4 divided by 4. So the radius of this circle is 31.080 inches when I round it out to thousandths. So that's about right from previous experience. I remember I was doing a radius of 28, 29. Now that's the inner radius is facing forward. The outer radius is going to be the inner radius plus the thickness of these pieces for the coopered headrest. Okay, so I'll add that thickness and I'll get the outer radius. And then I've got a jig that I've designed that swings my router back and forth along that curve on both the inside and outside radiuses. So this is a pretty involved process, but it really produces a nice effect when you're done. So I'll get started on putting this together, but I wanted to show you some of how I'm figuring out the radius of this headrest, the inner radius and the outer radius, and that of course will determine the coopering angles between these pieces. So I'm going to have to think about that for a while and come up with a formula for that. Okay. And the coopering angle is directly related to the circumference of the circle. So if I've got a bigger circle, I can tell already that I'm going to have less of a coopered angle. If it's going to be straight, the angle for coopering is 0. Okay.